All right, so here is where we're going to deviate a little bit from what we've been doing before. Before, we've been drawing our derivative number line, and we've been saying, okay, it's defined for all numbers, so we have our different intervals. Here, however, our function is not defined for all real numbers. Our domain was t greater than or equal to 0. Specifically, our domain came from looking at that radicand quantity greater than or equal to 0. So what we need to do is not consider every number under the sun. We're only going to plug in for the domain interval. So we're not going to consider anything to the left of 0 because the function is not defined to the left of 0. So this is a little different than what we've done before, because before we've had it defined for all real numbers. Here it's not defined for all real numbers, it's only defined 0 to infinity. So that kind of supports the realization that t is equal to 0 is not a critical number, and that the only critical number we need to consider is 9/4. So we put that critical number of 9/4 down. And again, because our domain is 0 to infinity, we just have this first interval from 0 to 9/4 and the second interval from 9/4 to infinity. And we are going to plug into the derivative. So there's multiple versions of the derivative here. I like to plug into the derivative right before we set it equal to 0. So if you look back at your work right before you set the derivative equal to 0 and the derivative does not exist, this was your most simplified form. So if we go right before we set those things equal to 0, that's going to be most likely the most simplified version of our derivative. So we'll have f prime equals -2 t to the 1/2 plus 3 over t to the 1/2. And then I need to plug in a number between 0 and 9/4. So I'm thinking 9/4 again is 2.25. So anything between 0 and 2.25 works. I'm thinking I'm going to plug in 1. And here is an easy way to do this arithmetic. What I like to do is just evaluate the numerator. So you have -2 square root 1 plus 3. That is going to give you a positive, right? Because you just have -2 plus 3. In the denominator, you have square root 1, and that gives you a positive. So positive over positive will give us a positive. And then evaluate something to the right of the 9/4. So maybe I plug in 3. So I have -2, 3 to the 1/2 plus 3 over 3 to the 1/2. Now, again, if you're using your calculator, you can go to your calculator and plug in the -2, 3. One thing to just mention, this 1/2 needs to be in parentheses because all of that needs to be raised to the 1/2 power. So it's not just caret 1 over 2. You do need parentheses to group that exponent together. And then plus 3, it gives you a negative. And then in the denominator, 3 caret 1 divided by 2 gives you a positive. So a negative divided by a positive, that mix of signs will give us a negative. So what we're seeing here with the positive is that that would be increasing, so we're going up the hill, and then the negative would be decreasing, so we're going down the hill. So at the end, they want us to find the relative max point and min point. You will notice here that you just have a peak, you just have a high point. So there is going to be no relative min point, and the relative max point will come at the 9/4. So remember, to find the actual point, we want to plug into the original function. And that original function was -2t plus 6 square root t. So I'll plug in the 9/4 into that original function. And this is one of those cases where with the square root, your calculator might be hard pressed to actually convert the decimal to a fraction. We can try it, but again, that square root makes me kind of feel like it's going to struggle with it. But let's see what it does. It should do it. It will give you 9/2. But I just want to mention, if your calculator doesn't do that, you would multiply these straight across. You would get -18/4 plus 6. And then the square root of 9 is 3. The square root of 4 is 2. So you would just reduce square root 9 to be 3, square root 4 to be 2. And then you could take 6 divided by 2 to give you 3. So you would have -18/4, take out a factor of 2, and then plus the 9, and then go from there. Okay, so it will do it, but just the square root, if you're having trouble with reducing that, it will reduce, just simplify what's inside the square root and then go from there. Okay, so the point is going to be, the max point will be 9/4, comma 9/2. So again, the x coordinate was 9/4, the y coordinate was 9/2. I do also just want to mention they are going to ask for where is it increasing and where is it decreasing. And there you want to be really careful about the fact that your domain was only 0 to infinity. So remember how like over here, especially if you plugged in, you would get something that's undefined. So when you're referring back to your domain, you're just going to have 0 to 9/4. So increasing will be parentheses 0 comma 9/4, and then decreasing will be 9/4 to positive infinity. And remember, increasing, decreasing always has parentheses. So even though the domain has a square bracket, we're still going to report our answer with parentheses.